Swayam Prabha. Digital India. Educated India.
Okay, thank you very much. So I'm going to start again. So my name is François Maréchal. I'm going to share this session on energy transition. So sorry for the delay. Our first speaker is a keynote speaker. I'm going to introduce Professor Widodo Wahyu Purwanto from University of Indonesia. So he's connected online. So Professor Widodo is a sustainable energy professor in the Department of Chemical Engineering in the Faculty of Engineering of the University of Indonesia. He earned his doctoral degree in chemical engineering from the Institut National Polytechnique de Toulouse. I can say it in French because it is in France in 1992. Prof. Widodo has served as the director of the Center for Energy Studies in the University of Indonesia from 2004 to 2007 and is head of the Department of Chemical Engineering in the same university from 2007 to 2013. He is currently the head of the Master Program in Energy Systems Engineering, director of the Research Cluster on Sustainable Energy Systems and Policy from University of Indonesia. He is in the editorial board of Natural Gas Science and Engineering from Elsevier and a senior member of the ICHE since 1990. His research focuses on sustainable energy systems modeling and policy analysis and natural gas technology and economics. He has been published more than 125 scientific papers and 4 books, and has guided or graduated 18 PhD students and guided 8 PhD students. So he's going to present his work on multi-objective optimization of hybrid renewable energy systems in the presence of uncertainty. So Prof. Widodo, the floor is yours. I would like just to ask a short request. So stay, keep your loudspeaker open because I will have to tell you if when we have to stop in case you are too long.
Okay. May I share my screen, please?
Yes.
Well, hello, good morning, everyone. Thank you, Prof. François, for the kind introductions. First of all, I would like to thank the committee, especially from ROTS, inviting me and giving the opportunity to share my view on this symposium. As you show in the screen, the topic today is the role of energy system engineering for designing sustainable energy system transitions. Let me start giving me a few words regarding my background. This is my small group, what we call it, Sustainable Energy System and Policy at University Indonesia. University Indonesia is the oldest university in Indonesia with a student body around 45,000 students located in suburb of Jakarta, Depok, and there's the old campus in Jakarta. Next, this is a member of my research group. This is multidisciplinary research composing to the faculty from Faculty Economics, Faculty of Science, and Faculty Engineering. And I have 11 students actually now doing the research. The topics is start from natural gas system and then renewable system, renewable energy system, and so on. Those the wide topic of research. This is outline of my presentations. I will focus on the three major issues. The first one is the challenge of energy transition modeling. And then the second is the role of energy system engineering in energy transition modeling. And I will give you some example of design toward the energy system, sustainable energy system. I think the three topics I will deal in these presentations. Let me start with this challenge of energy transitions. As you know, the international commitments currently respond to climate change, especially for the net zero target, and then the main strategy to decarbonization of this kind of energy system, mainly using the renewable energy, and then using the what you call it the electrifications of end users, and then using the emerging technology like biohydrogens, net negative technology like carbon capture and storage, and BECCS, bioenergy with carbon captures. And this is key of technology that already mentions, and these characteristics of energy to is capable to decarbonize of energy system. The first one says using a renewable energy and low carbon electricity, of course. And then because intermittency of variable renewable energy, we need energy storage like a pump hydro storage or battery. And then using the net negative technology and so on. And the variable renewable energy actually lead generations and demand imbalance due to the intermittency of supply, also due to the utilization of the electric vehicle, like this electricity load is very different with current conditions. Those high penetration renewable energy also need a solution, including the sector coupling, energy storage, also grid connection among the continental or among the island. As you know, that Indonesia have many islands. There's how to interconnect among the islands. And the third is majority of this kind of technology or an emerging technology is not yet commercial. Those in terms of energy modeling, I think is create uncertainty how to predict the future maturity of this kind of technology is quite challenging. This is the challenge of energy system transitions. The first one is energy system to reach net zero. Of course, it's quite different comparing to the current energy system based on fossil energy, especially change in terms of physical system, because infrastructure of this kind of new technology is quite different, and then consumer behavior, and then the market role. For example, you have the future have a peer-to-peer market, is more the retail competitions, And then the second is the renewable energy or low carbon electricity is the key role, but another problem is for industry, for example, is hard to decarbonize is due to the high intensive fossil utilization currently, mostly coal or another fossil fuel. The possibility in transition towards sustainable energy, of course, need integration between the energy system, of course, environment, economic, and social, or the political aspect, because the complexity and climate change, I think, is a huge dot. The energy technology only is not cannot answer the high questions regarding how to mitigate climate change. As developing country, Indonesia is passing to challenge because how we can achieve net zero without sacrificing the energy security currently. The geopolitics of fuel, especially Portugal, currently have huge tensions. Those have the constraint for the energy transition. Also, developing country, we have a limited capacity on financings, and also the carbon lock-ins, especially for producing country like Indonesia, rich of coal. I think is how to change this kind of industrial structures. Is the remaining questions is how to solve that. And the last one is energy transition also should be make attention on the uncertainty regarding the intermittent of the renewable energy. Finance is also uncertainty of the future deployments of this kind of emerging technology. Next is let's me move to the role of energy system engineering and designing the energy system transition or energy modeling. I think they are the emerging approach to model the kind of energy transition. The first one is should be integrate of new technology with the conventional technology, and then integrate multi-energy carriers like electricity, hydrogen, and the cooling, heating, and so on, using sector coupling, power to X, or combining not only process but also electricity centric model. You can combining this kind of approach, and then of course resolving the temporal spatial resolution to the wind or the solar resources is depending on the space and temporal, and also interregional linkage between energy and energy. Also the role of digitalization, smart grid, and then take uncertainty of in the short term period, in the long term of energy system planning, and also technology progress. And then to respond to just transition, especially for the country have the struggle regarding to achieve the energy transitions, I think we need to look at on the socioeconomic equality, and then behavior change and sustainability aspect. This is the illustrations of how the energy system engineering need to be extended their boundary, and then the linking with another another system like a socio-economic system and environment system. I think is very important, especially in macroeconomic aspects, energy market, and also and social aspect, also the change behavior, lifestyle, and also the environment aspect of sustainability. Sorry. Next, we'll give you some example that we are doing in my research group currently. Next, please. This is, we developed our model since 2015, and what we call it energy transition model, UI. This is based on the time model actually developed by Asiam. We have our license regarding this model, and then we developed to case 4 case of Indonesia specifically, and then we start with simple assumptions, and then we improve time to time. In this first step, I make assumptions Indonesia is one system, is not multi-regionals. And then next is we make some better regarding the assumptions regarding the multi-regional aspects of the country. And then we induce with sector coupling between energy carrier like electric vehicle, power to gas, and so on. We have collaborations with Imperial College and also UC Berkeley actually for develop this kind of model. Sorry. This is the illustration how we develop this model. The first one is Indonesia is like one system, and then second is we have about 9 major islands in Indonesia, and then the last one is we have interconnected between islands with what we call it super grid, and also the interconnections primary energy and also electricity. This is very interesting regarding the complex system in archipelago country. This is our typical research. The first one is we would like access how to decarbonize our power sectors. What we call it 100% renewable energy. It is we can achieve the net zero target from Paris agreements. In this research revealed that we cannot achieve the target Paris agreements due to the limitations of renewable energy. Actually, in Indonesia, we have limited space, continental space. Those the capacity of solar energy is limited. We have also small capacity in wind with low speed wind, but we reach in geothermal and hydropower. This kind of technology is most appropriate for this tropical country. And also we have seasonally not very different because we have just dry season and wet season. And then maybe Ramadan seasons is quite different. This is not like a 4-season country. I think it's very unique for tropical country. And the second one is we have study regarding how we assess our current policy, especially in power sectors, and then comparing to the Paris agreements. It is how it can achieve the Paris agreement. They show that the increase of the carbon emissions is very very high in the current policy, but in the Paris agreements, we have a difference, what we call it, carbon budget regarding this in the case of power sectors. I think the role of renewable energy to achieve the Paris agreement in power sector in Indonesia need the share of renewable energy is around 80%. Those I think is very challenging because the investments is maybe triple or quarterfold of the current policy. I think it's need the huge investments regarding this kind of scenario. And this is the third my study collaboration with UC Berkeley and Imperial College. It's how to make a decision on coal phase out in electricity. I think it's interesting the result because Indonesia have the what we call a dilemma between producing country coal and then we do coal phase out in our country. Thus, the impact of this kind of research, and we observe that impact of the power sector actually is not severe because currently the electricity sector is still monopoly by governments, or what we call it vertical integration with single buyer. Those the most severe impact of net zero emission in this upstream sector, especially in the coal sector. I think this is huge impacts in the net zero emission because the revenue, net revenue is, we can estimate around 2,000 billion US dollar is loss of benefit. Those I think is should be good managed because we have disruptions in coal sectors. And in the same study, I have the result regarding the super grid position with among the islands. This interesting can be improve the share of renewable energy among the country. We can increase using the super grid idea, and then we can reduce the energy storage, actually mostly battery and another energy storage, but we should be invest the grid quality, the huge investment on grid connecting among the country, because Indonesia have what we call it disparity, most economics in the west, and then the remote or marginal demand in the east of part of the country. I think this is very challenging for the research. And we have also the topic research regarding superstructure optimization to find pathway, some pathway, this with municipal pathway to electricity. And then we have also the productions optimization regarding the what we call it green urea production, because the ASEAN country mostly consume for agriculture is urea. And then we have options using pathway what we call it green or blue ammonia, and then we apply this kind of optimization to find the best the optimum pathway for the long-term predictions. And then I think in case of Indonesia, we have a giant gas field in Natuna near the Singapore, but we have what we call it a huge composition of CO2 is around 70%. This field is now exploited with development. Those we find the strategy how to develop this kind of gas reserve with high content of CO2. And then we have idea to combine with what we call it green pathway and gray pathway. Those we elaborated this kind of pathway for long term. Those we obtained the blue product is chosen start from 2040, 2040, and then the case of 2060, I think is very interesting because using the electrolyzer, the excess of oxygens can be used as three reforming processes, combine the steam reforming, dry reforming, and partial oxidation. This pathway is used for the long-term dose, combining steam reforming and blue products, methanol or synfuel. This is we use the multi-objective optimization superstructure to find the pathway appropriate to develop for long term, multi-period. This is also the optimization strategy for fuel blending. Currently, Indonesia using the what we call it biodiesel farming, actually from palm oil, the mixing farming and petroleum diesel. But the composition is currently 30% in Indonesia, but it's not comply with the engine specification or fuel specification due to what we call it instability of farming. Thus, we have an idea to blend not only palming, but also we adding the hydrated vegetable oil or drop-in. Thus, we obtain the composition optimal and in several scenario quality of fuel. Thus, I think is very interesting. We comply with Euro 5, Euro so. Those and other case is also we assess the sustainability of this kind of biofuel by considering the criteria of social aspect, job creations like that, and then the economic aspect, and another is environment aspect. Those I think is very interesting research. And I have also the techno-environment assessment regarding the blue methanol, mostly combining the CO2 from power plant or from gas processing. The CO2 source is much cheaper is from the gas processing or from fertilizer. The concentration is very high comparing to the blue gas. Those this kind we can assess when the blue methanol can be compete with the conventional one. I think is very interesting. And another research is combining capture the chemical looping with what we call it multi-product power and blue methanol. Then we can assess the environmental performance and also the economic performance and technical of course. And I have another study regarding the CCS industrial cluster, because in South Sumatra we have a cluster of industry, and then we have also the cluster of upstream oil and gas. We have a lot of what we call it depleted oil and gas reservoir there. Thus, we can combine the source of CO2 and sink of CO2 in the same regions. Thus, we can build what we call it CCS operator, and then we have evaluate the feasibility this kind of business. But actually, Indonesia is still no carbon tax actually. Because the next maybe the government maybe apply the carbon tax or cap and trade regarding the pricing of the carbon. This is, I come to the last of my presentations, the takeaway. The first one is sustainable energy system design and to achieve net zero required, of course, integrations between energy technology, source, services, sector, and also actor, for example, governments, player, and so on. Those holistic energy system transitions or net zero energy include also the include also wider economic interactions, environment, social, policy aspect. Those process system engineering need to extend the boundary, especially time and scale, also interdisciplinary field, because we need another field, economics, environment, and social aspect of Earth. And then design sustainable energy system transition need to consider also the uncertainty, the future technology or emerging technology, especially for hydrogen, carbon capture, and so on. I think need effort or investment or R&D or deployments, huge effort to deploy this and the appropriate time regarding the target. It should be remember also the energy transition, not only transition, but we should be have assure the energy security for the current condition. Thank you very much for your kind attention and time. If anyone any questions, I will happy to answer. Thank you.
Okay, thank you very much for the presentation. So, Professor Widodo, the floor is open to questions. It seems that there are no questions, but I have one, so it's good news. Could you go back to the previous, the last slides, because I think that you are highlighting something which is very important.
This one?
Yes, this one, the last bullet. I think it's very pertinent to say that there are I don't know if it is uncertainties, but the role of emerging technologies that are not seeing a profitability today. So could you comment a little bit on this and what is your vision about this?
Yeah, thank you very much for interesting question. I think the commitments to deploy this kind of technology, for example, the carbon capture. I have a study regarding the carbon capture. Indonesia is not have the what we call it, the capacity storage is not huge. If we deploy, for example, the CCS or CCUS, I think they have limitations regarding the what we call it, the correct data regarding the capacity of storage. Because Indonesia is not like another country where you have a saline cavern and so on, but Indonesia mostly the depleted oil and gas reservoir mostly. Those I think it's a challenge for huge investments, and also even the hydrogens. Hydrogen is good, but remaining what they could challenge regarding the hydrogen and so on need to be commitment international regarding the investment. So mostly like developing country in Indonesia is the current G20, of course, the developed country is committed to give Indonesia $20 billion US. I think it's huge, but if my calculations, if we decarbonize the sector, power sector, upstream sector is most huge comparing this kind of investment for disruptions of the upstream upstream revenue. This especially for Indonesia, you have, the many regions have the revenue, the region is different of this the upstream activity. How to manage the change of this kind of industrial structure, and then I think the just transitions mechanism is very important. Thank you.
Okay, thank you very much. Are there other questions in the audience? If not, I propose that we applaud you because it was a very nice presentation. And thanks a lot for participating.